Find the area of parallelogram ACEG. We'll use the formula for the area of a parallelogram to solve this problem. Area A equals base B times height H. The base of the parallelogram is GE. Now, since this is a parallelogram, we know that the top and bottom have the same length. So GE is the same length as AC. And we're given that AC is 28 feet. So the base, GE, is also 28 feet. Okay, now we need to find the height. The height is the shortest distance between the top and bottom of a parallelogram. It always forms a right angle with the base. Notice that the diagram gives us the length of side GA, not the length of the height. However, because this triangle is a right triangle, we can use the Pythagorean theorem to find the length of the sides. Remember, the Pythagorean theorem says a squared plus b squared equals c squared, where a and b are the lengths of the sides, and c is the length of the hypotenuse. Additionally, since we have a right angle and a 45-degree angle, we know the other angle must be 45 degrees, and we have a 45, 45, 90 isosceles triangle. Since these two angles of the isosceles triangle are congruent, the two sides opposite those angles are congruent. Because these sides are the same, we can simplify the Pythagorean theorem to a squared plus a squared is equal to c squared. That's 2a squared is equal to c squared. The hypotenuse, c, is 15 feet, and we can substitute that into the formula. 15 squared equals 225. So we have 2 times a squared equals 225. We'll divide both sides by 2 to get a squared equals 112.5. Taking the square root of both sides, we have a is approximately 10.6. So the height of the parallelogram is approximately 10.6 feet. Now we can go back to our formula for area and substitute in the values. So the area of the parallelogram is approximately equal to 28 feet times 10.6 feet. Simplifying, we find that the area of our parallelogram is approximately 296.8 feet squared.